today, 5 indirect proofs. This is for geometry. Okay, indirect reasoning. All possibilities are considered, and then all but one are provided or proved false. The remaining possibility must be true. Not something we use a ton in geometry, but we need to make sure we practice it and we're able to do it. Okay, an indirect proof is a proof using indirect reasoning. Okay, steps for writing an indirect proof. Okay, you're going to start off. State as a temporary assumption the opposite or negation. We learned about that back in chapter 2, I believe, of what you want to prove. So if we say Mr. Shell loves coffee, we assume that Mr. Shell does not drink coffee. Okay, that would be the negation, or does not love coffee. Okay, show that the temporary assumption leads to a contradiction. Okay, contradiction in our proof most of the time. And they conclude that the temporary assumption must be false and that what you want to prove must be true. And you'll see examples of this and some great examples of when this works. In the first step of an indirect proof, you assume as true opposite of what you want to prove. Okay, and I know that kind of sounds odd, at least it did to me when I first read it. So, okay, here's an example. Okay, we're going to write the first step of an indirect proof, so just doing the negation, which we've already done. Back when we had to do negations and contradictions and counterpositives and all that. Hopefully that's ringing a bell. Suppose you want to write an indirect proof of each statement as the first step of the proof. What would you assume? So this says an integer n is divisible by 5. So then an integer n is not divisible by 5 would be our answer. Okay, so is not divisible by 5. Okay, I didn't write that down. Hopefully you don't need me to. We just talked about it. This is going to be mostly words, so there won't be a ton to write down. Okay, if you need me to, I'll write it down on this one. Suppose you want to write an indirect proof of each statement as the first step of the proof. What would you write? This is the same direction as the last problem. You do not have soccer practice today. So what's the opposite or negation of that? Well, you do have soccer practice today. Okay, you don't say you do not have soccer practice. Okay, and I'll write this down for those of you guys who would like that. Okay, you do have soccer practice today. Alright, that's the first example. We only got 3 of them today. Okay, problem 2, identifying contradictions. So these all lead us into our indirect proofs. So, which 2 statements contradict each other? FG is parallel to KL. FG is congruent to KL. Can that be possible? Can you have 2 congruent segments that are also parallel? Yes. Okay, FG is perpendicular to KL. So when we look at this, can 2 lines be parallel and perpendicular at the same time? No, that's a contradiction. Right, so we are going to circle 1 and 3. Those 2 things cannot simultaneously be true. Okay, parallel means you never intersect. You have the same slope. Perpendicular means you have opposite reciprocal slopes that intersect at a 90-degree angle. Okay, let's go ahead and move to the guided practice. Which 2 statements contradict each other? XYZ is a cube. Okay, that means all angles less than 60. Triangle XYZ is scalene. Can all angles be less than 60 degrees and also not have any sides that are the same? Scalene means no equal sides. Yes. XYZ is equiangular. Can you not have the different sides? Or can all your sides be different and you have the same angle? No. No. If you're equiangular, you're also an equilateral triangle, which means you're not scalene. So our contradiction here is 2 and 3. Okay. These two examples, we're building us up to this last example for the day, or last example for this section. Given ABC is scalene, proved angle A, angle B, and angle C all have different measures. So we are going to assume the negation of our given fact, okay? Of the proof. Assume temporarily the opposite of what you want to prove. What do I want to prove? I want to prove that A, B, and C all have different measures. So what would be the opposite of them having different measures? Two of them having the same measure. So that's what I'm going to assume. Assume two angles have the same measure. We then know, based off the converse of the isosceles triangle theorem, okay, which sounds like a lot, but remember, in an isosceles triangle, you guys might not be able to see that with the recording, okay? Okay, if you have these two sides equal, then these two angles are also equal, okay? But we learned the converse, that was the isosceles triangle theorem. The converse of that states that if those angles are equal, then we know the sides are equal. So if we have two angles have the same measure, then by the converse of the isosceles triangle theorem, we know that two sides have the same. So then by the converse of the isosceles triangle theorem, two angles or two sides opposite, congruent angles are equal. Okay? Hopefully that made sense. Conclude that the temporary assumption must be false and that what you want to prove must be true. So, if we had two angles that were the same, then we have two sides that are the same, which can't be true because we're given the fact that ABC is scalene, so we write that down. Since triangle ABC can't be isosceles, it is scaling. There's a little roundabout way of showing that. Okay? Because if you had two angles, you could have three. But if you can't have two angles that are the same, it obviously can't be equilateral. Hopefully that made sense, or equiangular. Okay, moving on. Last guided practice for the day. Okay, assume temporarily the opposite of what you want to prove. Okay, so we're given 7x plus y equals 70 and x doesn't equal 4. Prove y can't equal 6. Well, let's let y equal 6. Assume y equals 6. And this is a great example of why, this is a great example of the indirect proofs being useful and making a very clear picture of how we know that these work. Okay, so assume y equals 6. Okay, show this assumption leads to a contradiction. Well, I'm going to start it up here. 7x plus y equals 70. Divide by 70. We're going to let y equal 6. I'm going to plug 6 in there. Sorry. Divide by 7. x plus 6 equals 10 minus the 6, x equals 4. Well, what do we know? We know that x isn't allowed to be equal to 4. So since that can't be true, and we know that's true if x equals 6, or y equals 6, we can assume that y does not equal 6. Okay? Since x cannot equal 4, we know x does not equal 6. Okay, I hope you guys have a great day and look forward to seeing you guys in class sometime soon. Hopefully.